I'm live. Woohoo! This is Math 60, section 4.3, page 1. And this is, I know you're all very excited, this is possibly the absolute most complicated and difficult part of this class. Woohoo! Let's hear it for 4.3. Yay! So the good news is that this is a very small part of Math 60. So do your best, try your best. I know you will. Those of you going on to calculus, however, this is going to become very, very important. So this is really preparation for calculus. To a certain extent, it will help you in Math 90, which is Algebra 3, and Math 95, Trig, or what other classes you take. But really, this is intended as preparation for calculus. So for those of you who are not going on to calculus, I just want to let you know, ask lots of questions. Be gentle with yourself when you're going through this. Some of this stuff is kind of weird and brand new. And hopefully, together, we'll figure it all out. So 4.3 is all about absolute value mixed with inequalities. So to begin with, we're going to start out with a brand new view of absolute value. So first off, we start with absolute value, as you've noted before. The absolute value of 3 equals 3. When you put in a positive number, you get the same number out. So that's an important distinction. Absolute value of a positive number does not change the number. However, if I take the absolute value of a -3, I get +3. So negatives go in and positives come out. When you put in a negative number, you get the opposite number as an answer. And then if you plug in 0, you get out exactly the same number. You get out 0. So our question is, how would we actually describe what the absolute value of x equals? Because we've got two different things that happen. So I know this is very exciting. This is possibly the first time you've seen something defined this way. So I know great excitement is right here at hand. The absolute value of x is defined as, and here we've got this brace, which means I've got two things going on at the same time. So the absolute value of x equals x. So in other words, x does not change when x is greater than or equal to 0. So if the number you're looking at is a positive number or 0, it's unchanged. Now, if absolute value of x, we're dealing with a negative number, if x is less than 0, so like -3, then when we put it in there, and here's the weird thing, you're going to say, wait, that's negative. And I'm going to say, no, the absolute value of -3 equals 3, which is the opposite of -3. So it's kind of weird. We're saying put another minus on it so that they cancel out and becomes a positive. Now, if you have never seen a definition like this where there are two cases, this is going to look really weird. And so I understand that. And you will not have to memorize this for this class. This is what we're going to use, how we're going to use it. So let me show you how to actually approach the problems. Basically, this is the way we're going to do it. If I tell you that the absolute value of x equals 3, then what I'd like you to do is to say, okay, in other words, something is hidden. I don't know whether the original problem was a positive or negative. And that's what these two cases are talking about. So what I'm going to say is, if the absolute value of x equals 3, then there are two possibilities. Either the original thing inside was actually equal to 3, or the thing inside was -3. Okay, so basically we break absolute value problems down to two possibilities. So what does this look like when things get more exciting? Well, when things get a little more complicated, we follow the same pattern, but there are a few more steps. Okay, so here we go. I'm trying to hide the bad news from you. I know you guys have these handouts, so you know how bad the news is going to be. So I've got the absolute value of 2x plus 5 equals 13. So I know this means two things. Either the whole thing inside 2x plus 5 actually was 13 to begin with, or the whole thing inside was negative 13 to begin with. Does that make sense? We don't know because everything that went in, it came popping out as 13. So it could have gone in as 13 or it could have gone in as negative 13. And so what we do is we solve the problem in both cases. So in this case, let's see, I get 2x equals 8 or x equals 4. And in this case, I get 2x equals negative 18 or x equals negative 9. So my answer is two answers. And you know what? I didn't write out my final answer here. So I could write as 3, negative 3, or I could write as plus or minus 3, or I could write it a couple other ways. So did I just say plus or minus? Wow, Freudian slip, plus or minus. I know some people are thinking that this is really, probably a diseased part of math. Absolute value, full disclosure, not my favorite. I had a lot of trouble with this when I was first studying math. So I do sympathize. So let's take a look at what's happening. So let's actually go back into the original problem. If x equals 4, 2 times x is 8, plus 5 is 13. Absolute value, we get 13. So what's happening when x equals 9, negative 9? 2 times negative 9 is negative 18. And then I add 5, negative 18 plus 5 is negative 13. And then when I take the absolute value, I end up with positive 13. So in other words, I can come at it with a positive number or with a negative number. And because of the absolute value, each of these will give me the positive 13 I'm looking for. Okay, let's take it another step further. Let's make it slightly more complicated. We've got somebody on the outside of the absolute value. So here's the thing. The this or that only works for whoever's inside the absolute value. If you have anyone outside, like here I have 3 times the quantity x minus 2 inside absolute value equals 3. What I need to do first is I need to get rid of this 3. I got to isolate this absolute value so I can do the this or that thing. So I'm going to go ahead and divide both sides, entire sides, by 3. So I get x minus 2 inside absolute value equals, and in this case, 3 over 3 is 1. Now, once I've got this, I'm going to come up here. X minus 2 inside absolute value equals 1. Now I do the this or that. So the whole thing inside, let me get my trusty yellow highlighter because nothing bad can happen when you're highlighting. True fact. You should have your highlighter with you at all times. So the whole thing inside, let's hope I give myself enough space. The whole thing inside either equals 1 or the whole thing inside equals, you're right, negative 1. Yay! I'm going to add 2 to both sides here. And so either x equals 3 or x equals 1. Now, this is something that can be initially confusing. Look at me putting them in the right order and everything. It's like I'm a professional. This can be confusing because I just said this one we're approaching from the negative and the positive side. And here these are both positive numbers, at which point you should be like, wait, what's going on? And the answer is we're coming in from the left and the right. So let's take a look. When x equals 1, plug in 1. You get 1 minus 2 inside the absolute value. That gives you negative 1. Absolute value of negative 1 is 1. And let's try 3. 3 minus 2 gives us positive 1. Absolute value of positive 1 is 1. So we come at it from the, oops, where's Mike? Come at it from both sides. Ooh, that was a visual aid, guys. And we finished page 1. Congratulations, you survived. Woohoo! Next up, page 2, possibly the Thunderdome.